I want you to imagine a scenario that, well, it plays out thousands of times every single day.
Oh, yeah, constantly.
Right. So imagine you're spending five, maybe $10,000, or honestly even more than that, on a massive critical upgrade for your home.
Which is a huge financial hit for anyone.
Exactly. You write this painfully large check, the installation crew packs up all their tools, their trucks pull away, and you just find yourself standing there in your driveway, just crossing your fingers.
Yeah, just hoping for the best.
You are fundamentally hoping that the incredibly expensive machinery they just bolted to your house actually works the way it's supposed to.
Yeah.
Because the truth is, you have absolutely no idea if they did it right.
None at all.
You are flying completely blind.
It is a distinctly unsettling reality when you lay it out in those terms. I mean, it really is.
It is.
But for the vast majority of homeowners across the country, that is precisely how the purchase of a new heating and cooling system operates. It relies on just a staggering amount of blind faith.
Which is crazy because we demand hard data for almost everything else we buy, right?
Oh, absolutely.
Like if a phone battery dies in 2 hours, we return it.
Yeah.
If a car doesn't get the advertised miles per gallon, there are literal lawsuits.
Yeah, massive class action suits.
But with HVAC, we just sort of shrug and trust the guy in the truck. Well, today we are going into a deep dive that completely dismantles that dynamic.
And it is about time we did.
Seriously. So our source material today revolves around a highly revealing transcript from Dave Hartzell.
Yeah, Dave is, well, he's a highly respected figure in this space.
Yeah, he's a master HVAC technician based out of Kingfisher, Oklahoma. He has 45 years of experience in the trenches.
45 years. You see everything in that time.
You really do. And he is breaking down the industry's own internal gold standard for quality. It's a protocol known as ACCA Standard 9.
And this standard, it's a remarkable document because it pulls back the curtain on how a home's mechanical system is actually supposed to be evaluated once the physical labor is finished.
Right.
It takes the guesswork entirely out of the equation.
So the mission for this deep dive is to explain the absolute necessity of verification. We are going to look at the stark contrast between a genuinely good, mathematically verified installation and a poor one.
A poor one that is actively burning your money.
Exactly. Burning your money and shortening the life of your equipment. And most importantly, we're going to arm you, the listener, with the exact questions you need to ask contractors before you sign any contract.
Those questions are vital.
Okay, let's unpack this. Before we can start interrogating contractors, we really need to understand the root of the problem.
Right.
Like, why are homeowners kept so deeply in the dark? And why is this specific industry so uniquely prone to a lack of transparency?
Well, to get to the bottom of that, we have to look at the framework of the industry's own rulebook. So ACCA Standard 9, which officially stands for Quality Installation Verification Protocols. It was published back in 2016.
Okay.
And it was specifically designed as a companion piece to another document, ACCA Standard 5.
So there's a 5 and a 9.
Right. And Dave Hartzell uses a really effective analogy to explain the relationship between these two. He points out that ACCA 5 is essentially the recipe.
A recipe. Okay.
Yeah, it defines what a correct residential HVAC installation should look like in theory. You know, it's the list of ingredients, the proper sizing, the duct design.
So it's basically the blueprint before the hammer ever swings.
Precisely. But ACCA 9, that is the inspector's checklist.
Oh, I see.
It is the rigorous set of protocols that dictates how to verify that the recipe was actually followed.
Because knowing the recipe doesn't mean you bake the cake right.
Exactly. It defines the exact measurement procedures, the allowable tolerances for the instruments used, even the specific weather conditions under which you're allowed to take those measurements.
Wow, so it's incredibly detailed.
Very. And it dictates what the technician must do if the results fall out of specification.
And this really exposes the core vulnerability for the homeowner. Because as a consumer, you don't know the recipe.
No, of course not.
And you definitely don't have the inspector's checklist. So the technician finishes up, hands over an invoice, maybe puts a hand over a vent to show you it's blowing cold air.
Right, the classic hand over the vent.
Yeah. And then they just drive away. And you're left paying a premium price based on a completely vague assurance that everything is just fine.
But fine is not an engineering metric.
No, it's not.
Fine is an opinion. And for decades, the industry has heavily relied on the subjective experience of the technician. I mean, if the air coming out of the register felt reasonably cold, the job was deemed a success.
I had to push back on this, though. Because if a system is fundamentally installed wrong, wouldn't it just break down immediately?
You would think so, but no.
I mean, it feels absurd. It's
Yeah.
like ordering a custom high-performance sports car, paying top dollar, and when it's delivered, the dealer tapes over the speedometer.
Takes the pitch shut.
Right. Locks the hood shut, hands you the keys, and says, just trust me, it's fast. Why hasn't consumer demand forced this industry to be more transparent?
What's fascinating here is the sheer invisibility of the failure.
The invisibility.
Yeah. An HVAC system is not like a sports car where you can immediately feel a lack of horsepower. A poorly installed air conditioner will still produce cold air.
It just might be doing it terribly.
Exactly. It might just be working 30% harder to do it, consuming drastically more electricity, and slowly destroying its own compressor over 5 years instead of lasting 15.
Oh, wow. So it's a slow death.
Right. The homeowner doesn't realize they've been shortchanged until the system suffers a catastrophic failure years later. So ACCA 9 fundamentally changes what the word documented actually means in this context.
Moving it away from just taking their word for it.
Yes. It forces a shift from a subjective opinion to an objective science, replacing that blind trust with verifiable proof.
So if ACCA 9 is the ultimate lie detector test for an installation, how does it actually work? Let's break down the anatomy of an installation to understand how a verified system operates compared to a completely unverified walk-around install.
Okay, let's do it.
Let's start with the physical hardware that shows up in the driveway.
Well, that is the foundation of the entire system. Before a single wrench is even turned, standard verification requires ensuring the equipment actually matches the engineered design.
Like checking the boxes.
Physically checking the model numbers to confirm the specific SEER and HSPF ratings.
I want to pause right there.
Yeah.
Because we see those acronyms on yellow stickers all the time. What do they actually measure?
So ESEER stands for Seasonal Energy Efficiency Ratio, which is basically the gas mileage rating for your air conditioning. And HSPF is the Heating Seasonal Performance Factor, which is the equivalent rating for heat pumps.
Got it.
The entire system is engineered based on those specific ratings and the nominal tonnage, which is the system's capacity to move heat.
But in the real world, equipment gets back ordered.
All the time.
Right. So a crew shows up. They don't have the exact condenser that was on the quote. So they just pull a different box off the warehouse shelf and install it. Does swapping a box really cause that much chaos if it's the same brand?
It completely destabilizes the system's performance.
Really?
Yes. An HVAC system is a precisely matched set of coils, blowers, and compressors. If you swap out a component with a different rating, the entire system's operating characteristics shift.
So you can't just mix and match?
Not at all. A verified install mandates that the exact model numbers, down to the specific refrigerant type, perfectly match the design documents before the job is considered complete.
Okay, so let's assume the correct boxes are bolted in. The next crucial phase seems to be about the system actually breathing. Airflow.
Airflow is the lifeblood of the entire operation. ACCA 9 requires measuring the actual delivered airflow and comparing it to the design values.
And the margin of error there is pretty small, right?
The tolerance here is incredibly tight. The actual airflow must be within 10% of the design specifications.
10% seems almost aggressively strict for a normal residential house. Hartzell gives a scenario in the source material where a design calls for 1,200 CFM.
Right, CFM being cubic feet per minute.
Exactly. But if the system is only pushing out 900 CFM, that is a 25% deficit. I get that less air is bad, but what is physically happening inside the machine when it's starved of air like that?
Well, when you have a massive airflow deficit, the heat exchange process just breaks down.
How so?
In the summer, if enough warm house air isn't moving over the cold indoor coil, that coil can actually freeze solid into a block of ice.
Oh, wow. Literally freezing.
Literally a block of ice. The system has to run endlessly to try and cool the house, which spikes your energy bill. And more importantly, it forces the blower motor to work under immense stress.
It's literally like trying to run a marathon while breathing through a cocktail straw.
That is a perfect analogy.
Your heart, or the motor in this case, is eventually just going to give out. And this ties directly into something called static pressure, right? They measure this in inches of water column, which sounds like we're suddenly talking about plumbing instead of air.
It is a very specific metric, yeah. But conceptually, think of static pressure as the blood pressure of your duct system.
The blood pressure. Okay, that makes sense.
It's a measurement of resistance. The blower motor is trying to push air through the supply ducts and pull it through the return ducts.
Right.
If the ducts are too small, or if there are too many sharp bends, the resistance goes up. The standard requires the technician to measure the static pressure and ensure it aligns with what the blower motor was actually designed to handle.
So if the static pressure is too high, it's a giant red flag that your ductwork is actively suffocating the brand new equipment you just bought.
Correct. And this is where the sequence of verification becomes so critical. You cannot accurately check the system's refrigerant charge if the airflow and static pressure are wrong.
Because they affect each other.
They are inextricably linked.
Well, let's talk about that refrigerant charge, actually, because this is where bad installations really seem to rely on total guesswork.
Oh, completely.
A poor installation usually involves a guy hooking up some gauges, glancing at a dial, and just saying, yeah, pressures look good.
And pressure alone tells you almost nothing about how the system is actually performing under a thermal load.
So what's the right way to do it?
A proper verified installation requires complex math. They have to measure either the superheat or the subcooling of the refrigerant.
Superheat and subcooling.
Right. Superheat is used for older, fixed orifice systems, and subcooling is used for modern systems with thermal expansion valves. It essentially measures the exact state of the refrigerant as it boils into a gas or condenses into a liquid.
And the standard has incredibly strict rules about when you're even allowed to take these measurements, right?
Very strict. ACCA 9 dictates that you can only verify the refrigerant charge when the outdoor ambient temperature is between 60 and 100 degrees Fahrenheit.
Okay.
Furthermore, the system must be running continuously for a minimum of 15 minutes before any measurements are taken.
Why the 15-minute rule? Like, what's happening during that time?
It takes time for the system to stabilize. The pressures and temperatures are fluctuating wildly when the unit first turns on.
Oh, so it's still settling in.
Exactly. If a technician measures the subcooling at minute 3, the reading is completely fabricated. It doesn't represent how the system will operate on a 95-degree day in July.
Wow.
If they are adjusting the refrigerant levels outside of those specific parameters, they are quite literally just guessing.
Which means they are gambling with the lifespan of your compressor.
Absolutely.
And the final checks in ACCA 9 look at the symptoms of all these underlying systems, right? Like the temperatures and the electrical draw.
Exactly. For a gas furnace, they must measure the temperature rise. Every furnace has an acceptable temperature rise range stamped right on the manufacturer's nameplate.
Usually something like 35 to 65 degrees.
Yeah, that's a common range.
Why is that specific window so critical, though? If the air is hotter than 65 degrees, isn't that better for heating the house? Like faster heat?
Actually, it's incredibly dangerous.
Really?
Yeah. If the temperature rise exceeds the manufacturer's maximum, it means the heat exchanger is getting too hot, usually due to that low airflow we discussed earlier.
Oh, I see.
And over time, that excess heat causes the metal to expand and contract too drastically. It will eventually crack.
And a cracked heat exchanger is bad news.
It can leak lethal carbon monoxide directly into the home's air supply.
Wow. Okay, so checking that temperature rise isn't just about efficiency, it's a literal safety protocol.
It is. And on the electrical side, verifying the voltage and the amperage draw on all the motors provides an immediate diagnostic snapshot.
Right.
If the compressor is drawing significantly more amps than its rated specification, it is crying out for help.
It's working too hard.
Yes. It indicates severe mechanical wear or a critical refrigerant issue long before the system completely shuts down.
So what does this all mean for the homeowner? I'm putting myself in the shoes of our listener right now, and the sheer volume of engineering we just discussed is totally daunting.
It is a lot of math.
Right. We've got superheat calculations, CFM deficits, static pressure in water columns, temperature rise tolerances. Does a homeowner actually need to memorize all of this thermodynamics just to avoid getting ripped off?
Absolutely not. And that is the brilliance of standardizing this process. You do not need to do any of the math yourself.
Thank goodness.
You don't need to know how to calculate subcooling or read a blower performance chart. What you must know is that your contractor is doing the math.
Got it.
You need the assurance that these specific physical realities of the system are being objectively measured, recorded, and verified, rather than just eyeballed by someone trying to get to their next job.
That is massive relief. So if the listener doesn't need to be an engineer, how do they actually hold the contractor's feet to the fire? How do you force them to prove they did the math?
You demand the receipts.
Which brings us to the absolute golden ticket of this entire deep dive.
The commissioning report.
Yes. Here's where it gets really interesting. Talk to me about this document, because from what Dave Hartzell describes, this sounds like the single most important piece of paper a homeowner will ever possess regarding their house.
It is the ultimate proof of value. ACCA 9 mandates the generation of a commissioning report. This is a comprehensive physical or digital record that documents the actual exact measured values for every single one of those verification areas at the exact time of installation.
So if a contractor hands me a generic photocopied form with scribbles that just say, system turning on okay, or temperature drop looks good, I should be highly suspicious.
You should reject it entirely. That is what Hartzell refers to as a useless walk-around checklist. A genuinely good install, typically executed by highly trained professionals holding advanced credentials like NATE certifications, it yields hard data.
Wait, define NATE really quickly for the listener.
Sure. NATE stands for North American Technician Excellence. It is the premier, nationally recognized certification program for HVAC technicians.
Good.
It's essentially the difference between relying on someone with a basic first aid kit versus a board-certified physician. Technicians with those credentials, or those working as Trane comfort specialists like Hartzell, they understand how to generate a true commissioning report.
So it's going to have real numbers on it.
It will list the exact CFM measured. It will show the decimal point of the static pressure. It will record the precise superheat calculation and log the outdoor temperature at the exact minute the measurement was taken.
And Hartzell refers to this document as diagnostic gold. And I can completely see why. Let's fast forward 3 years. It's the middle of a brutal heat wave, and suddenly the house is incredibly humid and the AC just isn't keeping up.
A nightmare scenario.
Right. But if you have that initial commissioning report tucked away in a drawer, you possess a scientific baseline.
It changes the entire paradigm of repair work.
Yeah.
The technician who responds to the service call doesn't have to start replacing random parts and hoping for the best.
They can just compare the numbers.
Exactly. They take the current measurements and lay them side by side with the startup measurements from day one. They can instantly see the divergence.
Like, oh, the pressure changed.
Right. Has the static pressure spiked because the homeowner installed a hyper-restrictive air filter? Has the subcooling dropped, indicating a micro leak in the refrigerant line? It turns troubleshooting from an expensive guessing game into a targeted surgical intervention.
It creates total accountability for everyone involved.
It absolutely does. It protects you as a consumer, giving you a legal and technical guarantee that you received the performance you paid for. And frankly, it protects the contractor too.
How so?
In the event of a dispute, that commissioning report is the definitive, unarguable record that proves the equipment was installed according to the unbending laws of physics and the industry's highest standards.
So we know the anatomy of a mathematically verified system, and we know that the commissioning report is the ultimate receipt. How can you, the listener, actively wield this knowledge?
You need an action plan.
Exactly. The next time your furnace makes that dreadful grinding noise and dies in February, or your AC blows hot air in July, what is your specific action plan?
It all distills down to an essential pre-project checklist. There are fundamental questions you must ask any contractor before you even consider signing their proposal.
Okay, let's play this out. Question 1. You are sitting at your dining room table. A contractor just handed you a quote for $12,000. What is the first thing you ask?
You look them in the eye and ask, will you provide a comprehensive commissioning report with actual measured values when the job is complete?
Simple as that.
Simple as that. But watch their reaction very closely. If they immediately say yes, and they can casually explain what metrics they will be recording, specifically mentioning airflow, static pressure, and mathematical refrigerant calculations, you have likely found a contractor operating at the level of ACCA 9.
And what if they hesitate? What if they give you a weird look and say, oh, sure, our guys always fill out a startup sheet for the office?
Then your radar needs to be on high alert. If they cannot articulate what data actually goes onto that sheet, it is a massive red flag that you are about to pay a premium price for a walk-around, unverified installation.
Okay, let's say they agree to the report. Fast forward to the end of the project. The new, shiny units are installed, the crew is cleaning up, and the lead technician asks for the final check. What is the crucial action step here?
Before any money changes hands, you ask to review that commissioning report right then and there. And again, don't let the engineering intimidate you.
Just look for the numbers.
Exactly. You are just verifying that the data actually exists on the page. Look for 3 specific indicators. 1, is there an actual airflow or CFM measurement listed?
Okay, check.
2, is there a specific superheat or subcooling number recorded for the refrigerant rather than just a check mark? And 3, is there a static pressure measurement recorded in numbers?
And if it's just check marks?
If those fields are blank or just say, okay, the rigorous work of verification did not happen, do not hand over the check.
That is incredibly actionable. But what if someone listening to us right now is thinking, well, I had a new system put in 2 years ago, and I absolutely did not get one of these magical reports. Are they just out of luck? Is there a way to verify an existing system?
There is a recourse. You can hire a highly qualified, credentialed contractor to come out to your home and perform an ACCA 9 verification audit.
Now, it is vital to distinguish this from a standard promotional tune-up, right?
Oh, absolutely.
This isn't the $49 spring special where a guy hoses off the outdoor coil and changes your filter.
Far from it.
Hmm.
An ACCA 9 audit is a comprehensive technical evaluation. The technician will meticulously run through all 6 verification areas, take the hard measurements, and produce that documented baseline for you.
That's great to know.
Dave Hartzell mentions in the transcript that he frequently performs these audits on systems installed by other companies, and the failure rates he finds are alarming.
I bet.
But the immense value is that once the audit is complete, the homeowner is no longer flying blind. They know exactly where the system is failing mathematically, and they have the leverage to make informed decisions about mitigating those issues.
If we connect this to the bigger picture, this deep dive goes so far beyond the mundane mechanics of heating and air conditioning.
If we connect this to the bigger picture, it is fundamentally a masterclass in consumer empowerment.
Truly.
When a massive mechanical system is installed and verified correctly according to the strict metrics of ACCA 9, the results are highly tangible in your everyday life.
You feel it in your wallet.
Yes, it means your monthly utility bills are visibly lower because your equipment isn't constantly fighting against a 25% airflow deficit. It means your house actually maintains a consistent, comfortable temperature without the unit running 20 hours a day.
It's doing what it's supposed to do.
By demanding a commissioning report, you are forcing the market to give you the efficiency, longevity, and comfort that you rightfully paid for.
To quickly recap our journey today, we dismantled the blind faith approach to home contracting. We learned that ACCA Standard 9 is the ultimate inspector's checklist.
The essential baseline.
Right, providing the dividing line between an amateur guesswork installation and a meticulously verified one. We explored how the physical machinery, the breathing airflow, and the refrigerant bloodline must all be perfectly balanced to prevent catastrophic stress on the equipment.
And we gave you the tools to ensure that happens.
Exactly. Most importantly, you now have the exact vital questions to ask before you hand over a single dime to a contractor. Demand the commissioning report. Demand the actual numbers. Look for the static pressure and the airflow data.
It entirely shifts the power dynamic from the seller back to the buyer.
It absolutely does. You aren't just protecting a metal box in your yard. You are protecting a massive financial investment in your family's daily comfort.
And stepping back, it really does make you wonder.
Wonder what?
Well, if our home HVAC systems require this rigorous mathematical verification just to ensure they aren't secretly suffocating or operating at a massive invisible deficit, what other massive hidden systems in our homes, or even in our daily lives, are drastically underperforming right now simply because we've never demanded to see the actual measurements